Please welcome Mario.
Thank you. Good morning, everyone. First of all, I'm glad that we have so many people here at this presentation this morning. As it was announced, I'm going to give a kind of a brief overview of European Processor Initiative, and I'm really looking forward to this project to go beyond the project itself and to create really a powerful HPC processor ecosystem in Europe. So here on this slide, we have a lot of buzzwords that we all talk about. When we talk about HPC, there is like artificial intelligence, data privacy, edge computing, connected mobility, GDPR, deep learning, autonomous driving. And when we talk about this and when we think about EPI, we can say, okay, where is EPI located here? And what we would like to say is, and here I represent the whole EPI consortia, European Processor Initiative is all about this. What I'll try to do this morning is give you some kind of like, first a background overview of how the EPI actually started its activities. And then, of course, since we just started a couple of months ago, there are no explicit results, but we are going to present some of the goals of the project itself. So first, a little bit about strategic interplay. Because when we talk about EPI, we cannot isolate EPI from the wider strategic decisions and moves that happened in the last few years here in Europe. So first thing is, I would say, what are the drivers for this? As we all know, because we are all from the HPC community, there are several important scientific and industry areas that require more and more HPC power. For example, the analysis of climate change. There are some reports that say that that the losses or the economic damage on some of the climate changes has been really significant. So predicting climate changes, it's very very challenging from the HPC perspective. Another thing, and this is something that is I would say very concerning, is that our population is aging. So with the aging population, and as we know, the majority of investment in the healthcare are coming from the diseases with the elderly people and with very complex diseases. So if we have the aging population, and Europe unfortunately has the aging population, we have significant pressure on the health system to be sustainable and to use IT to try to kind of keep the levels of healthcare the same, while of course having more and more people and more difficult and complex tasks to do regarding the healthcare. So of course, not only that, but when we talk about the energy, when we think about designing, simulating, and creating new energy efficient systems, we have a lot of new ways of computing things. And for that, there is more and more need to have the HPC delivering some of the results from the complex algorithms. And then, of course, we come to the cybersecurity. Today, everything tries to get connected with a lot of connected systems and a lot of data being collected. The importance of securing that data is extremely important. And also what we need is we need to ensure that the algorithms that we execute are controlled by us, and we also need to control the access to the data. Of course, there are a number of different domains where cybersecurity plays one of the key roles. And of course, Europe is interested to keep that control locally. Going from kind of, like scientific approach and big social challenges, we have also the industry. And the industry is trying to use more and more HPC in order to create better products, to come to the market faster, and to kind of outcompete because of usage of complex simulations or verification of products or even generating new products heavily depends on how able you are to basically do some of your investigations or research in advance using simulations rather than doing it on the actual product itself. European industry, of course, is interested to have the capability of using this strong HPC ecosystem to enhance the product, to deliver more competitive products on the market. Last but maybe not the least is sovereignty. Europe needs to have its control of the technology and approach for many of the reasons. To protect data, to protect economical interest, and to kind of have a second solution in case of many embargo-like solution that may happen in the future. We don't know what will happen, so we need to prepare for all of scenarios. When I talk about European Processor Initiative, I would like to give maybe a brief kind of like couple of year history how the project actually started. So first, the Horizon 2020 program within its framework partnership agreement call was looking for consortia that could deliver European technology for low power HPC. And the challenge there was to foster basically European HPC ecosystem with European technology. As we know, today European technology in the HPC is maybe not as strong, but one of the kind of ultimate goals of this call was to get that technology up so that it's comparable to some of the competition that is globally present. What was expected from that call was that we strengthen the competitiveness and leadership of European industry and science, especially in the technology area. Second thing, of course, is potential to deliver European microprocessor technology with drastically better performance and power ratios compared to what is existing on the market. Of course, this is one of the, I would say, buzzwords and most important things that we know, which is performance and power ratio, which is important in today's HPC ecosystem. And of course, which something that I will going to mention later on in my presentation, to cover important segments of the broader HPC and big data markets. I will give you, some hints. Why is this impact very important and especially important for the EPI? In the same time, when I said strategic interplay, I would like to give you maybe a little bit of overview of, several things happened in the same time in the last 2 to 3 years. So in the same time, in March of 2017, during the Rome meeting, there was European Commission launched something that was called EUROHPC Declaration. And with that declaration, several member states at that time signed an agreement to commit to work together to acquire, build, and deploy an integrated world-class HPC infrastructure in Europe. This was sort of a route to the activities that happen later on. And until today, most of the European countries joined in signing this EUROHPC declaration. As a result of this declaration, in probably 1 year behind us now, so in January of 2018, European Commission proposed to establish something that is called EUROHPC joint undertaking. So, they said, okay, we would like to invest, to start with, 1 billion to start world-class European HPC infrastructure. And this EUROHPC joint undertaking is very important in the aspect of European Processor Initiative that I'm going to tell you about today. So, starting with that, so end of last year, the EUROHPC joint undertaking was, formally formed, and it started its activities. So the participating states for the EUROHPC started very, important task to actually bring the European HPC ecosystem to the levels that we're expecting and that were strategically defined in the earlier agreements. So what is the primary ideal goal of the EUROHPC joint undertaking is to combine joint procurements for new top-level European HPC infrastructure and make joint investments in leading technology, software application, and the ecosystem around that infrastructure. So the focus, and this is important for EPI, the focus of EUROHPC is infrastructure, but also research and innovation. And the same thing, because those two cannot exist without each other. So if we have infrastructure, we need the research and innovation to be able to use that top-level infrastructure, and in the same time, if we have top-notch applications, scientists, and industry, we need, top-notch infrastructure to be able to follow that. So the interplay of those two is very important, and this is, of course, very important for the long-term interest of developing the European processor. I heard that probably many of you have seen already this picture, but these are the participating states in the EUROHPC joint undertaking, which means that I would say most of the Europe is already involved, which is, very important for us. So, when we talk about the focus of the EUROHPC and European Processor Initiative, of course, first thing is, as I said, the infrastructure part of the EUROHPC investment is to invest at, petascale and pre-exascale systems, knowing that, this week there is a call and there are a lot of people working on preparing, the petascale system offers, for this. And then the second part is supporting European Processor Initiative to actually develop, using European technology, systems that could, in the future, be part of pre-exascale and exascale systems, which is important for us and for the EPI technology to be included in the later European high-end systems. What is also important to see the ecosystem that is behind it. EUROHPC would like also to create something that are called centers of excellence and HPC competence centers, basically to be able to pass the knowledge and to distribute widely the knowledge about the usage of HPC and the advantages of using the HPC on that top-level infrastructure that is going to be built, not only to selected number of partners, but to wider community, especially the SMEs. Because as we know today, SMEs are very difficult in trying to get what they could do with infrastructure like that. So basically, investing into teaching the SMEs, how they can benefit from usage of that infrastructure is very important. I mean, not just to build the infrastructure, not just to build the processor, but basically tell the wider community, okay, now here you have it. You should better use it because it's a benefit for you. So this wider ecosystem of bringing the knowledge about the European HPC is also important to this. Now, when we talk about building the processors, I mean, there is obvious question, why do we need to build a European processor? Of course, there is number of, explanations that we can say, but I would say many of those fall into the same category. There are many of reasons why we need that. There are some news articles that we see on a daily basis from all over the world about this threat or that threat, or this industry being able to do something that the other industry is not being able to do. So basically, processors control almost every part of our lives today. From what we do at home, from where we drive, for where we work, or the complete system that is around us. So it's very important to have basically the option how to choose our processor. Of course, there's some, as I said earlier, there's some potential restrictive options that can happen in the future. So we have to prepare ourselves for eventual things that may or may not happen. And of course, if you have a supply coming from more sources, then all of us as customers, having more options give us more negotiating power, which is also important, both for the industry and both for us as a community, because the prices may be lower or the access may be more efficient, or a combination of that. And of course, then again, we come to sovereignty issue where Europe would like to be able to know what is behind the control of some of the key things of our everyday life. But when we talk about that, okay, design the processor. There is an HPC market for that. But is HPC market large enough to start designing your own processor? Many would argue that maybe, it's questionable, right? So to have sustainable initiative, yeah, we are talking about long-term interests, right? Not a couple of years and then, we don't know what's going to happen. So when we talk about that, we have to think about, what are other markets where we can use that technology, because we are going to invest serious efforts and finances into delivering new processors. So what are the additional markets? So in Europe is extremely strong in the automotive industry. So, this is one analysis. I think the data is from 2017, but basically Europe is manufacturing almost 1/4 of all passenger cars in the world. And it generates almost 100 billion trade surplus for that. Also, another very important point is from the R&D perspective, out of all industries, European automotive industry invests the most in R&D. And because of the volume and because of the investments, this is, I would say, an obvious choice of selecting, second or additional potential market for our processors. And why is that needed? We all know that today's cars, or cars that are being designed today for the future, they try to go into directions of having, being able to drive, with the driver, or actually helping the driver, or without the driver. So the autonomous driving is kind of like a big thing in the automotive industry. And in order to be able to handle the processing of all of the data that is required to actually perform that, there is a lot of processing power needed. So the actual match of, I would say, HPC-like processor in the car of tomorrow is absolutely needed. What we are talking here is we are talking about 100 teraflops processing power that is needed for class 4, a little bit less, and class 5, a little bit more of future cars. And that is a lot of processing power that needs to be built into the car. And of course, we have the power envelope in the car that is even more sensitive than the HPC, big servers. So the idea was to actually create a processor that is going to be able to be scalable so that we can take the advantage of other markets, not just the HPC exascale market, to be able to create a sustainable ecosystem. And this is one of the, I would say, key things that differentiates a project from being, pure, as we said in the start, Horizon 2020 research project to actually be an industry project. And for that, of course, what we also consider, if we are going to design a processor that is scalable, we are also looking at some other markets that are obvious later on. Of course, cloud market is one of those, and there are some other markets that may be interesting for us in the future. So I tried with these initial slides to explain this strategic, I would say, interplay, how the European Processor Initiative is going to affect wider range of products, services, areas, and parts of our life. So who is European Processor Initiative? This is us. This is a very strong consortia of 23 partners, led by industry, led by Atos, who is coordinator, and that is able to cover the challenges of designing the new processor, creating the ecosystem around it, and, as I will explain, bring it to the market, which is, of course, the goal of this. The three major goals of European Processor Initiative, of course, is to create and to design a general purpose processor for HPC, high performance, low power. Then create accelerators, because as we all know, the approach to take the exascale systems being highly performant with the general purpose processor is very difficult. So we have to, kind of try to make a heterogeneous approach where we are going to use the accelerators as well. Here, we are trying to design a RISC-V based accelerator, and we are going to build the computing platform for the autonomous cars. Very challenging goals, yes. What is our mission? Well, as I said, the mission is to deliver European technology for the processor. The mission is to address the needs of European industry, not only HPC, but automotive as well as the other. And of course, it is our goal to be able to deliver this processor for the future European pre-exascale and exascale systems. One key thing is to be able to offer end-to-end data security. The vision is that, we are going to, deliver the processor, low-power processor for servers and cloud. We're going to deliver the processor, the kind of reduced version of the processor for the automotive industry. And, in the automotive industry, beside the autonomous driving, we have the connected cars that, that are also being designed right now. And the impact would be to strengthen the European industry for this and have Europe taking the leadership in some of those technologies, bring the European processor technology to the market, and of course, try to access some other markets. I have to come back to the consortia itself. When we are talking about those, very ambitious goals, we can see that in this consortia, we have major industry players that are driving the initiative. Apart from that, we have, very strong research centers. Being here, ETH Zurich being one of the organizers here, we have ETH Zurich also being a partner. And, of course, we have number of partners, strong partners and globally strong partners in the automotive domain that are working to get the automotive system as well. So we have all the key players. We have ambitious goals, and we just, started our activities in December of last year. We are, striving to get those results executed. Now, let me talk a little bit about what is European Processor Initiative chip? Of course, as I said, we just started, so I cannot give you, real hardware to show and give you, but I can disclose with you some of the high-level architectural things. So one of the, I would say, key things about EPI is something that we called common platform. So what is a common platform? Well, the common platform is basically our architecture, our look at the architecture, where we would like to combine different architectural features to build the processor that I just explained earlier. What is the EPI common platform architecture contain? We're going to have general purpose processors, starting with the ARM one. And we are going to have several accelerators in our architecture. So we have MPPA Calrace accelerator. For example, they're working a lot in the automotive domain as well. So very interesting combination. We're going to have EPAC, which is a RISC-V accelerator with long vectors that are going to be able to deliver basically the number crunching aspects of the system. We're going to have Menta's eFPGA. So basically what we'll be able to do is to do some reconfigurations in the chip when it's already manufactured. And of course, the common platform allows us to include some other modules or cores into the system later on to create the families of processors. So for example, crypto cores are potential candidates, and some other cores. And it's all based around something that is organized as a 2D mesh network on a die. Of course, in order to create more powerful processors, we'll be able to have multiple dies with, connection, from die to die. We're going to have external connections, from die to the outside world, to the other chips. And of course, connections to memories, on chip and off chip. When we talk about, this common platform architecture, what I just said is it's very important for us that we envision the architecture to be scalable and extendable in the same time, to create more processing power or to be able to deliver for certain target markets, certain members of the processor families to be tailored for certain needs. When we talk about RISC-V as one of our core activities, with the RISC-V ISA, we'll try to develop a very powerful accelerator. And within that accelerator, we are going to have, again, multiple units like, vector processing unit that is going to be able to, provide us with a, high-end feature for the, vector processing, stencil, tensile accelerator, variable precision. So basically within that core, we are trying to create the future architecture for the EPI. Because, we can absolutely say that, this is not a short-term and quick development phase. What is also important is that having a B&W group, consortia, and them being interested in to create the automotive system, we have direct user, I would say, of the architecture itself. So it's very powerful combination where together with the user we design the architecture. So it's not that the architecture goes out of the fab and then you accommodate your application to the architecture, but we are designing the architecture together with the automotive partners that hopefully will get us, like perfect match for the automotive segment. And then what I said earlier, the automotive segment is very important for the sustainability of the whole ecosystem. Then when we talk about end-to-end security and the usage of the certain members of the processor families, then we talk about cars talking to each other, or smart cities and cars connection. Then we have the cloud infrastructure, the HPC infrastructure, and connection between all different possible players in the ecosystem with the same general architecture, but with different family members of the architecture. And the big advantage of the common platform is that we can fairly easy create different family members here. So of course, probably you would like to know what is the roadmap. Kind of general overview of our roadmap is our first generation family, which is RIA family, is going to be based on, I would say, certain external IP, because we would like to get some solutions fast out, get some results out to basically justify the initial phases of the project itself. We are going to have a common platform, as I explained earlier, but we are going to have, some of the external IPs that are going to be embedded into RIA family chips. And then based on that, we are going to drive the ecosystem. Because the ecosystem is important. I mean, you can deliver the technology in the architecture, but it is important that you have the users, the programmers, the designers know the architecture, start using it in their designs, or start programming or optimizing the architectures. Now, going beyond that, for our second generation family, which was codenamed Kronos, we are going to, in the meantime, develop a lot of our own IP. And with that own IP, we are going to sequentially replace some of the initial IP that was obtained in the first generation family. With that, trying to get more and more architectural control over the whole design. What is also important is that, for the second generation family, we are targeting some, ambitious goals in the pre-exascale and exascale domain, the chips being out there. And there is a future third generation family that is, kind of still way ahead of us. What you can see is, here, I talked a lot about the automotive aspect of that. So in the first generation, we're going to have the proof of concept, not actually having something in a car yet. Whereas with the second Kronos generation, we are going to have the automotive processor designed there and optimized. This is a general roadmap, and how it is going to work on the actual market. Beyond the European Processor Initiative Consortia, there is going to be something that right now we call FABLESS company. Well, the FABLESS company is going to be like the one-stop shop for both the IP and the products. So it would not be feasible, of course, to have the 23 or more partners, trying to negotiate the licensing and production and manufacturing and marketing. We are going to create one company that is going to basically collect the IP and try to first go to the 3 markets that I mentioned earlier, and then try to go to the other markets later on. The importance of this is that future customers have somebody to talk to, somebody that can basically license the technology. And it's very important for us because all of the internal IP between different partners is going to be collected and synthesized in one place. When I talked about scalability, the EPI would like to start with core drivers. So HPC, automotive, service, and cloud. Of course, AI and big data being very widely accepted as keywords that without AI you don't have a presentation, right? If you don't mention AI, the presentation is not good. So yes, we are going to cover that aspects as well. And of course, there are some application domains that are also very important, that are safety critical, like Industry 4.0 and space and aeronautics. And to conclude, I'm almost on time. And to conclude, I would like to say that EPI is crucial for the HPC strategy of the European Union and to resolve some of the societal industry challenges that we have. Europe, with the EUROHPC joint undertaking, has made already strategic decision to invest and to strategically support this initiative in the wider aspect. And of course, the European Processor Initiative CHIPS effort fall directly there, and the interplay of this technology with the ecosystem is very important for the success of both these strategic goals of EU and strategic goals of European Processor Initiative. And with that picture that very much looks like, you know, the view on the mountains that we had here in Lugano, well, maybe not exactly, I would like to thank you. And of course, I'm open to any questions that you may have. Thank you.